Hey guys, this is part 2 of the interview with Dr. Stuart Phillips. In part 1, we covered protein quantity, how much we need. And today we go over protein quality, amino acids, bioavailability, and some more on plant and animal protein. Now before we dive in, I just want to address some questions that came up with part 1 real quick. People asked if the protein intake ranges that Dr. Phillips talked about are per kilo of total body weight or lean body weight. In general, it's per kilo of total body weight. Same as the RDA. RDA also works like that. Reason is most people know how much they weigh. So it's just easier to give people that number that they can apply immediately. So for example, for the 1.2 grams of protein per kilo of body weight range, for a woman weighing 150 pounds, that's 68 kilos approximately, so it would be 81 grams of protein a day. For a man weighing 180 pounds, that corresponds to 80 kilos, so it would be 96 grams of protein, ballpark. Now, if someone has a lot of body fat, very overweight, obese, morbidly obese, something like that, Dr. Phillips explains it's better to use your ideal body weight to calculate protein. Otherwise, you could end up with hundreds and hundreds of grams of protein just corresponding to the fat mass, okay? Another question was about calling fiber an anti-nutrient. In nutrition, this term just means something that can interfere with the digestion and absorption of other nutrients. It doesn't carry a negative connotation necessarily. It's more like a property, right? It could even be a good thing in some contexts. If we eat some whole grains like oatmeal, the carbohydrate gets absorbed gradually. So we get a normal response in terms of blood sugar levels, unlike what happens if we eat a bunch of purified table sugar, all thanks to fiber. I know there's a ton of misunderstandings about these terms on the internet and all kinds of different connotations, but in nutrition science, saying that something is an anti-nutrient is not a statement about the overall health value, and it certainly doesn't deny the health benefits of fiber. Same for the expression high-quality protein. Some viewers were very shocked that Dr. Phillips said that animal products tend to be higher quality protein. This is common terminology in protein metabolism research that refers to amino acid content and digestibility. It's not an overarching statement about the health value. So if we take 100 grams of steak and 100 grams of beans, or 100 calories of each, however you want to match, the steak is going to contain more amino acids and it's going to give you a stronger anabolic response if we're looking at these two foods in isolation. That's what's meant by quality protein in this specific context. It's a very objective statement. It doesn't mean that you can't get enough protein or all of your protein from plants if you prefer. Dr. Phillips explained that you can. He even explained how to do it, and we had the two menus at the end of the video, one with and one without animal products, both very high in protein. So there's no contradiction. Some viewers asked about protein and lifespan, which is a whole research field in and of itself, and I have a lot of interest in it. Actually, some of my research was in this area, so we're definitely going to dig into that in the future. And the last point before we get into the interview, some viewers were just very distraught with the video in general and asked if it contradicts everything we've ever said on this channel. I gotta tell you, I talked to Stu for an hour and I never felt like we were in disagreement on anything fundamental. The gist of his message is that based on his research, he sees some potential benefits of eating a little bit more than the RDA. He suggests 1.2 grams of protein per kilo of body weight ballpark instead of 0.8. We can agree, disagree, and look at the evidence, but I don't see anything shocking about that. I don't see anything that flips nutrition on its head. And even if he had disagreed with me fundamentally, that's not a problem. We want to bring people on who are at the top of their field so we can learn from them. Whether they agree or disagree with me is irrelevant, right? In fact, if they disagree with me, good. I want to know why. As long as it's a scientific argument, I want to know exactly what they disagree with, and maybe I'm wrong. Of course, that doesn't mean we uncritically accept what people say, but we want to hear what they've learned over decades of studying a scientific topic, like Dr. Phillips has done with protein metabolism and anabolic response. And on that note, some viewers also asked to have more evidence shown on screen, to show the research of the guests as they go through it. And can't argue with that, right? That's 100% on us, it's not on the guest. Nobody sits down for an interview and cites a study at the end of every sentence. I don't do that when I go on podcasts. So that's 100% an editorial decision on us to show the research as the person is going through it. This interview format is still very new to us. It was the second or third time I've done it. So we're trying to figure out the best way to do it and the best way to present it to you. The feedback seems to be that the viewers prefer to see the guest's research shown on screen as the guest is explaining it and explaining their views. So we're going to try that, starting with today's video. And we also went back and added more references to the description of part 1. So without further ado, here is part 2 on protein quality. Enjoy. We're on the chapter of protein quality. Can we touch on those metrics, the famous, the PDCAAs and the DIAAS scores? Can you briefly explain what those are and what they measure and maybe some of the limitations?
Yeah, so the PDCAAS, the protein digestibility corrected amino acid score, you understand why we shorten it to PDCAAS. I mean, essentially it's a measure of protein quality. It's done in rodents, usually rats, and really it's about comparing one protein and its ability to support growth versus a gold standard protein. And the gold standard is, well, you pick a few, but sometimes casein, sometimes egg-based proteins, casein being a milk-based protein, and then you compare whatever it is that you're feeding, and rats grow in a linear fashion. So it's a growth assay, and I think that's important to emphasize to people. The main comment or criticism of it is that first, it's in rats. I think the second thing is its growth, and so does it apply to people or rats even going in the opposite direction, losing muscle mass? And we don't know the answer to that. And then the last part, the digestibility, is assessed by taking the feces that the rats generate and measuring the protein that's in there. And so it's what we call fecal digestibility. And without, and everybody goes, oh my goodness. And I'm like, yeah, you're right. It's not fun work to do. At the end of our ileum, which is our small intestine, and not the processing through our large intestine, where we have microbiotic populations that do all kinds of things that we're now becoming aware of, including making essential amino acids, recycling nitrogen, all kinds of things that 10, 20 years ago, you'd been like, really? And now I'm convinced it's happening. And so the digestibility is different between the two scores. So the digestible indispensable amino acid score, or DIAAS, effectively uses ileal digestibility. So it puts a little catheter in at the end of your ileum, the end of your small intestine, samples from there, and doesn't get confused by what happens with your gut microbiome. I know it's a subtle difference between the two. And the other thing is the cap, is the PDCAAS was capped at 1. In other words, anything that had scores above, proteins that had scores above 1, people said, well, that's not relevant because growth is all that matters. And DIAAS has sort of rewound that a little bit and said, well, there are other things that protein does that aren't just growth based, that makes the individual proteins that score higher actually more valuable. And we could bash the merits of that around, but the DIAAS score is thought to be a little bit more valid for humans. The hard part is it's used a lot in internet arguments. The reality is nobody uses it in any food labeling system or anything beyond an academic discussion. So, right. That maybe says something to some people about, is the score really useful? I think in certain scenarios it could be, but it's probably a very subtle difference, hence the long-winded explanation.
So the PDCAAS was essentially discontinued, right?
Yes and no. I think like as a scientist, I could say I think DIAAS or the DIAAS score is a better score or a better way to score things. I think it's more physiologically relevant. And I do think that it highlights some proteins that have a score of better than 1, right? And whether that's an issue or not, you could argue. So we still use the PDCAAS score in the United States. It's still the standard for labeling proteins. It's still used. In Canada, we don't even use that. But I mean, let's just, for the most part, most people are still using PDCAAS scores and labeling and everything else like that. The only place it begins to take prominence, I see you out there on Twitter, is there's little Twitter debates about, oh, this DIAAS, this and this. And my point is, for most people, in westernized society, it's not an issue because you've got good access to food. protein quality is a non-issue. In a food desert, low income, food scarcity, older people with reduced appetite, it could become an issue. And then I think that the DIAAS score would be the one I would like to use, but I am appreciating that the differences are probably pretty subtle.
And are most of those experiments carried out in pigs, or am I wrong about that? And then the other experimental thing that I got from the literature was that it's mostly raw foods that the pigs are fed, right? Raw grains, raw beans, and it's usually single foods, right? So just give one food at a time and measure. And so how do those real caveats? How do those carry over to figuring out what's best for us in terms of how we eat? We cook foods, we eat a variety of foods mixed together. We're not pigs.
Yeah. So I mean, there have been a really small number of studies done in people with an ileostomy, so that you can actually sample the digesta. You can imagine. I mean, there's probably a handful of studies with those folks. The next preferred animal that has a gut closest to ours are pigs, and then after that it becomes pigs, dogs, rats, et cetera, et cetera. So yeah, the caveats around the majority of the data that are out there being generated, and now we're using artificial gut digestion systems. So it's basically a tube, and there's acid and there's enzymes that come in, and so these are artificial digestion systems. The reality is there's always some lost in translation. Is it really applicable to humans? And you're right. I mean, a lot of these things are done on isolated proteins and not foods per se, which is a drawback. We don't eat isolated proteins for the most part. And a lot of the foods that are in there are raw and not cooked. And we know that the cooking improves the digestibility of proteins, from plant-based sources, or if you have a bean or a seed, if you sprout the seed, in other words, if you let it sort of crack the outer hull open, you get better access to it. And so, fermentation, it's another way of preparing these foods that would enhance and improve their digestibility for sure.
I've seen some studies that look at isotopes as a measure of digestibility in humans. Are those well accepted, or is it still something that's a bit preliminary?
Interesting methods. Our lab uses a lot of stable isotope measures in humans, and I'll say at this time, I think it's still pretty experimental. There's some methods that are out there right now that I think are probably going to be more broadly applicable to and to foods as well. But it's expensive work to do, and it would only ever be on sort of a limited number of proteins. The biggest drawback we have with all of these scores right now, particularly DIAAS, is understanding the digestibility coefficient. And so when we eat, as you say, mixed foods, if we've got the beans and the rice, and we do this and we do this, or what's the food prep method, et cetera? Do you boil them? Do you steam them? All these kinds of things. We don't know the answers to those questions. And so I think people are making, reasonable assumptions at this point. People say assumptions. I'm like, well, guesses, we'll call them guesses, educated guesses. And, we might be off by a little bit. I don't think it's a big deal, but there's a lot more work to be done in this area to really understand the digestibility aspect of a lot of these protein sources.
So maybe an assay that is more informative in terms of final outcomes and things that we ultimately care more about. And I know that you've done a lot of work on hypertrophy and lean body mass and these more real world outcomes for a majority of the people out there. They probably don't care too much about the absorbability or the MPS measurements, but they want to know, can I hold on to my muscle mass? Can I put on some muscle? I was watching one of your interviews on another channel. You're a popular guy. You're on every channel. But you were going over kind of the history over the last couple of decades of how these ideas of protein and protein quality in animal versus plant, how this has changed. So I'd love if you could give a little your version of that. And kind of how, Yeah. How
Yeah,
does that
yeah.
go?
I mean, like I've been doing. I've been a McMaster now for 24 years, so I've probably been doing this whole protein thing for close to 30 years, and my opinions have changed on this. I think asked me 10 years ago, 20 or 30 years ago, I said, oh yeah, like plant-based proteins are nowhere near as good a quality, and veganism is people are going to be close to protein deficiency and these sorts of things, and fast forward to now, that's not the case. There's no question about that. The question is, does it put you at risk? And I think it's like a lot of things. I mean, we can be omnivores and eat a crummy diet, and nothing we do is ever going to compensate for some of the food choices we make. And you can do the same thing if you're a vegan. I mean, there are good vegans and bad vegans. For the most part, protein quality, when you're eating in sufficient quantities, is not an issue. It's not something that's going to limit growth or anything else like that. Just despite some, I think they're ridiculous position stands from certain physician groups around kids and vegan diets, and this is going to become, if you're in a food deprived, food scarce country, and we're talking about famine regions and underdeveloped and non-first world, or whatever the right term is, then it's an issue. Growth stunting is an issue, but it's not for the most part in most societies, particularly if you're judicious about how you plan your diets. But as you point out, when do you really care about protein? Well, when you're a kid and you're a child and you're growing, then we care. We don't want to stunt growth. We don't want to, because that's associated with poor outcomes from a health perspective. And then once you're an adult, I suppose the question is, at a certain point, you've sort of stabilized in your 20s and 30s, and with aging, things begin to decline, and muscle mass is one of them, and that's what we call sarcopenia. And then the question becomes, what type of protein intakes do we feed those people to maybe mitigate the decline? And nothing's going to stop aging; like, it's still going to keep going in a downward direction. But we'd like to not have the curve be this and have it be something like that, so that it's a slower rate of loss. And protein's effects there are very subtle. They're next to impossible to detect with any methodology that we have currently, unless you have a lot of people and they're in the study for a long time. So we default to paradigms where we're trying to really push people to grow muscle, lifting weights, the hypertrophy aspect, or we're looking at patient populations who are on bed rest, and we know for a fact that they're going to lose muscle quite rapidly. So, to the most important questions for kids in North America, unless you're in a food desert or a very low income family, protein's not a big deal. For older people, I think we're still wrestling with the issue of protein and what will be optimal to try and take the curve to this as opposed to this sort of decline. But the big contributor to this versus this is also physical activity, right? The more active you are, the more muscle you hang on to, particularly if you're lifting weights or doing some sort of strengthening activity, then you're going to be in better shape.
So I see maybe a parallel between, there are some things that someone on a predominantly plant-based diet has to be more aware of than someone who's more on an omnivore diet. And maybe there are things that are the other way around. An omnivore needs to be more aware of than a plant-based eater. But so B12 would be one obvious example. Not that B12 can't happen on an omnivore diet. B12 deficiency can't happen, it can. But obviously somebody who's eating a lot of plants or all plants needs to be keenly aware of B12 and make sure that they're getting some. And maybe the idea of protein is similar, where people who are getting most of their protein from plants need to be more consciously aware of the amount of protein that they're getting, making sure that they're eating a variety of plants, and that they're getting some of these richer, more protein concentrated sources like beans, lentils, chickpeas, tofu, all of these things, and not just rely on salads and grains alone, or some of these other things. Maybe is that fair to say, or is that
yeah, no, I think that's a fair comment on all of the things. I mean, I it tends to be, when you talk to people, it gets very polarizing. Food is I don't need to tell you, but it almost borders on sort of a religious zeal that people discuss their food in there, and I can see lots of arguments for more plant-based and vegan lifestyles when it comes to other issues around, ethics and animal treatment and environmental impacts. And I try to stay away from those, mainly because I'm not an expert in that area. But from a nutritional standpoint, I think those are very fair comments. Yeah.
Okay, and I think just to add a little bit more nuance, I think in certain contexts, for example, an older person with low appetite, a situation where getting enough protein could be an issue. I see value of actively recommending introducing more animal products. Could make total sense, and trying to go on a full whole food, full plant-based in those contexts could be hard to get enough protein or enough specific amino acids.
Yeah, I mean, one of the again, the truisms around, plant-based protein is to get the type of protein intakes that we're talking about. Now, for the young people, it's a non-issue, but you do have to eat like a little bit more energy, because the, beans and lentils are not as protein rich as, drinking milk or eating a piece of meat. And so you have to eat a little bit more energy to get there. If you're an older person, that may be a challenge. And, let's be honest, if you're going to say, like, here's 250 grams of lentils versus 4 ounces of meat or, chicken or beef or something like that, it may be that the person would have liked to eat the meat as opposed to 250 grams of lentils. But, if they have bad dentition, or if they, they have a hard time chewing or swallowing, all of those become barriers. And then, you say, well, what can we do? And this is when, the supplemental protein becomes a potential option. So, whey-based, soy-based, whatever base it wants. But, that could be an acceptable substitute for sure.
Okay, can we shift gears a little bit and talk about leucine, because it's very important in terms of anabolism as a main anabolic trigger. Can you give the basics for somebody who's never heard of it? What is leucine? Yeah. Why is it important? And how can someone get enough of it?
Yeah, great question. I mean, I think the easiest way is to, remind people that, proteins are made up of strings of what we call amino acids. There are 20 different amino acids. 9 of the 20 are essential. In other words, we need to ingest protein. We can't make these amino acids ourselves. We can make the other 11. And one of those 9 is leucine, for reasons that it's hard to, for me to explain or for me to even understand. Leucine is the amino acid that, particularly in muscle, kickstarts the process of making new muscle proteins. And in every protein containing tissue, we're constantly making and also breaking down, making new proteins and breaking down old proteins. And so we call that protein turnover. And the process of making new proteins is specifically stimulated by one single amino acid, and that's leucine. You really then, after that, have to have all the other essential amino acids there as bricks in a pile that you're going to put into new proteins. So not surprisingly, again, animal source proteins are particularly rich in leucine, and so they are a little bit more effective on a gram per gram basis than plant-based proteins. It's stimulating protein synthesis. There's no question about that. You can get it in lots of supplements. I'll just warn people that it doesn't taste great. It's, as amino acids go, you taste it and it's extraordinarily bitter. So it's a tough amino acid to work with if you're going to supplement it. Just be prepared for a poor taste profile. But and once again, there are exceptions in the plant-based world as well. Corn, as an example, is, as a source of protein, and most people go, well, how much protein is in corn? The answer is not much, but we grow a lot of corn, and we don't eat all of it. And so, could we use corn protein, which is, for reasons, again, I don't know, that is rich in leucine as a plant source protein? So, that's something to think about as well. There are plant-based sources of leucine, and I know everybody on Twitter will be upset if I didn't tell people about pumpkin seeds, and they are, for reasons we really don't understand, they're high in leucine. So plants can do the job, but it's much more efficient and easier with animal source proteins.
So these studies that look at lean body mass or look at hypertrophy, I've seen a few where they try to match for grams of total protein when they're
Yeah.
comparing, for example, whey to soy or pea protein or something like that.
Yeah.
And if you match for grams of protein, you typically see, or you sometimes
That's
see, an
where
advantage
yeah.
of the protein source. And then in studies where they match not for total grams of protein, but for leucine, then they tend to sort of even out.
Yeah, exactly. Yeah. And I mean, I think that the results you've just described kind of highlight the importance of that single amino acid. And so if you make the conditions isoprotein, then animal proteins, as you say, tend to have the higher leucine content and work better. If you make it isoleucine, so it means eating a little bit more of the plant protein, then everything becomes a wash. And you know, I've been fortunate to be involved with a good friend of mine, Hamilton Rochelle, in Brazil, and his group conducted a study, I think, that probably upset a lot of people or surprised a lot of people, where they compared a completely plant-based or vegan-based group of people lifting weights with an omnivorous group, and they were both eating 1.6 grams of protein per kilo per day, and they got the same muscle mass gains, same strength gains, and everything else like that. And so it highlights is that if you get enough protein, these issues around leucine and protein timing and everything else like that just become peripheral details. So that's, I think, something that most people would sort of say, oh, I didn't expect that. Or a lot of people were like, no, there's no way, these were novice lifters and that sort of thing. And there's been studies done in other populations, and the bottom line is the differences just aren't there. So.
And is that with protein powders and supplements like that, or how are they getting to 1.6?
Yeah, usually with protein powders, soy-based in the vegan group and whey-based in the omnivorous group. And I think that the main point is that it's tougher to get that amount of protein when you talk about food, and so protein powders are the easier way to do the study for sure.
With leucine, is it 3 grams? Is it 2 grams per meal? Is there like a threshold, or is that not well defined?
Yeah, I wish I knew. I wish I could give you a better answer than I'm not sure. We haven't done enough or definitive, I would call them protein sort of dose response studies to know exactly how much. I think in young active people, 2 grams is more than enough. No question about that. I think when you get to older people, and particularly if they're inactive, then it could be as high as 3 or 4 grams per serve or per meal to try and hit that threshold. So it goes up with age. It goes up with inactivity. Similarly, we've done studies where we've put a knee brace on younger people's legs for a week or 2 weeks at a time, seen the muscle atrophy, and that muscle looks like older muscle. So inactivity is definitely a contributing component to this. But when people say, "Oh, is it just activity?" and I'm like, no, there's lots of reasons that aging happens. Inactivity just happens to be part of it. And if you're a worm or a mouse or a rat or a human, as you get older, you do less. It's just a fact of life. And you can do all kinds of things to kind of tweak that and everything else like that. But I don't think that you can overcome it just through activity. But that's a big part of it for sure.
So that got me curious to look at leucine amounts in those menus that we showed you guys in part 1. And both menus had a substantial amount of leucine, and it wasn't that different. Same general ballpark. And I wasn't aiming for leucine at all when I was throwing the foods together. It just turned out like this. And that's a good takeaway for these 2 protein videos so far, that overall dietary pattern is number 1. Sometimes in scientific studies, they look at foods in isolation. They pit food A against food B, and that makes sense. But at the end of the day, we want to put all of this knowledge together and think in terms of whole diets. Some foods in there might be low or very low in protein, some might be very high. That's fine as long as the overall is solid. Next week we have part 3 and the last one of this interview with Dr. Phillips. We're going to look at protein timing over the course of the day, also low carb diets and their relationship to fitness, and finally, can we gain muscle and lose fat at the same time? All of that and more next week. Let me know your questions below. Take care. See you next time. you.